Hello everyone and welcome to a session on conditional puzzles. Now conditional puzzles are very important for exams like LSAT because the analytical reasoning section in LSAT is completely based on conditional puzzles. Now there are major two variations in conditional puzzles. One is conditional selection or grouping. The other one happens to be conditional sequencing or ordering. So we would be doing these two variants in two different sessions. So in today's session, we'll be focusing more on conditional selection and grouping. So there are a couple of basic things that we need to keep in mind before we approach condition-based puzzles. Let's have a look at them. So things that are supposed to be kept in mind. First thing is some relationships are fixed. What do I mean by that? In couple of the questions you would find that P would always go with Q. So this is fixed. Wherever P goes, Q would go. Okay, so this is an example when I mean some relationships are fixed. Some questions you would see that the relationships are variable. In a question we are talking about four groups. We are saying P would only go to group 1 or group 3, completely ruling out the possibility of P being in group 2 or group 4, but still there is no fixation as to which group P would be into. Could be in group 1 or could be in group 3. You have to pay extreme attention to the words that describe or limit relationships like only, exactly, never, always, must be, cannot be, and some similar sounding words which either gives you the direction or define the relationships between the variables in that particular question, or they kind of put a restriction or put a restraint on the variables in that particular question. Now, one important thing that is different from puzzles or sitting arrangements, and that is where conditional puzzles would be slightly different, that in puzzles and sitting arrangement, we actually solve the entire problem, and once we have the solution, we can, we have the answers for all the questions that are being asked with that particular arrangement. In conditional puzzles, we cannot do that. Each question is an individual question for us. Okay, so we have to solve each question separately from the other questions in the set. And this is very critical, that no information except what is given in the original conditions should be carried over from one question to another. It is quite possible that the information is only given pertaining to a certain question. And if it is not being mentioned, we cannot use that information while solving subsequent questions. So we have taken a couple of examples here to elaborate the usage of these words and to understand how conditional grouping or conditional selection questions have to be approached. So let's get started with the examples now. So here we have the first question, which says a combination of 3 fabrics is to be chosen out of 7 fabrics, which are F, G, H, J, K, L, M, and there are certain conditions which are to be met whenever I am choosing 3 fabrics out of 7. What are the conditions now? Now, when I'm solving questions like this, it is very important to note down the conditions in a kind of coded form or a symbolic form outside the sentential form. Okay, so that I am reduce the work of going back to the question and reading it again and again. What I mean by here, let's have a look at the question. If F or G is chosen, the other must also be chosen. So can I say F and G, they are always coming together. So F and G are a bundle. Why? Because if I'm taking F, I have to take G, and if I'm taking G, I have to take F. Pay attention to the word must here. So my first condition is that F and G are essentially coming together. Second condition, H and J cannot be chosen together. So I'll simply write H cross J. That tells me this combination can never happen. Condition number 3. Either H or F or both must be chosen. To make any valid combination, one of these, either H or either F or H and F both, must take place, because there's a word must here. Let's have a look at the questions and see how these questions have to be approached. Which of the following conforms to the condition? We'll look at the options and we'll see if any of the options is contradicting with any of the conditions, so that cannot be our answer. Option number A, FHJ violates condition number 2, that H and J cannot be together. It violates condition number 2. This cannot be my answer. Option number B, FKL, condition 1 is not being followed, that if I'm taking F, I have to take G. Option C, again condition 1 is not being met here, that F and G will always appear together. MJL, what is not being met here? Condition 3, because I cannot see H or F or HF, both of them coming together. So correct answer is option E here, HKM. Here condition 3 is being met because I've already taken H. I have not taken J, so condition 2 is not being violated. I have not taken F and G both, so I am not even violating condition number 1. So here we have ruled out 4 options based on the conditions they have been violating. Moving forward. If K is chosen, which of the following could also be chosen? Okay, so we have taken K. Again, we'll look at the options. Option A violates condition 1 because I've taken F and I'm not taken G. On the same logic, option B is ruled out. Option C is also ruled out. Option D can work for me. Option E would not work for me because here condition 3 is not fulfilled. So option D is H, L, K. I've taken H. I've ensured that condition 3 is being met and I've not taken F and G both. So my answer here is option D. Now in this question, a book club holds 2 discussion sessions each summer. The discussion leader of the club is selecting 2 groups of books, group 1 and group 2, and there are 7 books which have to be divided in 2 groups. And we have been given that group 1 will have 4 of the books and group 2 will have 3 of the books. And there are certain conditions. Now these are the original conditions which will always hold. And as I've mentioned here, that in some of the questions there would be few conditions which would be specific to a given question, as we can see in the language here. But first let's understand the original condition. Our first condition is T cannot be in the same group as U. So we have T cross U. They both have to belong to 2 different groups. Second condition, if X is in group 2, then Z must also be in group 2. Third, if Z is in group 1, W would be in group 1. So these are the 3 conditions which have to be met in all the circumstances. Now let's look at the conditions which are given specific for this question, which are T and Z are in group 2. So group 2 can have 3 books. Out of those, 2 have already been given to us, T and Z. And there's only 1 place left in group 2. Now, as I've placed T in group 2, U would be in group 1 because they cannot belong to the same group. Now, when I use condition 2, that if Z is in group 2, that can only happen when X was also in group 2. So X is in group 2, so the remaining other 4 members would be in group 1. But we might not have to make this entire arrangement because our question was If T and Z are in group 2, any of the following books can be in the group 2 except, we don't have to make this arrangement by the simple fact, the moment I am putting T in group 2, I am excluding U from being a member of group 2, because T and U cannot be in the same group. You can never be a part of group 2. So we might not have to do this actual arrangement. This question can be only answered by this fact. Moving further, and again quickly noting down conditions. So here a question is, if Z is in group 1, if Z is in group 1, now according to condition number 3, if Z is in group 1, W must also be in group 1. Then which of the following must be true? Now if Z is in group 1, what can we say about X? Can X be in the group 2? Absolutely not. Because if X would have been in group 2, Z should also have been in group 2. But here we are seeing Z is in group 1, leading us to that X is also in group 1. And who could be the fourth member of group 1? Anyone among T and U. And the balance member, which is V and Y. Let's have a look at the options. T is in group 1. I have no surety because T could be in group 1 or could be in group 2. Now V is in group 2. Yes, because there's no other place where I can allocate V as of now. V is in group 2. Yes, there is a surety to it because I have already completed the members of group 1, which was Z, W and X, and anyone among T and U. So our answer here should be V is in group 2. This would be always true given the conditions here. So here we have another question. 10 freshman students LMNO, PQ, RS, T and U arrive at Egghead University for their first term of college. They were told that they have been assigned to 3 dormitories, which are Genius Hall, Intellectual Center or Brainy Building. At least 3 of the 10 students are assigned to each dormitory. So there are 10 students. Minimum 3 have to be in each dormitory. So the only possible split that can happen is 3, 3, 4 in any order. That means 2 of the dormitories would have 3 students each and one of the dormitory would have 4 students. Now let's have a look at the conditions. MPU are all assigned to separate dormitories. So I'm writing it like this: M/P/U, and slash is a way to let me know that I cannot combine them in any way. L and T are all assigned to the same dormitory. So I am writing L and T is one group. Both O and R are assigned to intellectual center. Okay. Now, so let's start with our arrangement. So we have Genius Hall, we have Intellectual Center and Brainy Building, 3 dormitories. Original conditions, it's already been given that O and R are part of Intellectual Center. Now let's have a look at the first question, and the first question itself has one of its own condition. If M and Q are assigned to the same dorm, which of the following cannot be true? So if I assign M and Q to Genius Hall, that means I cannot assign P and U to Genius Hall because M, P, U cannot be assigned to the same dormitories. So P and U, one of them will go to Intellectual Center and one of them will go to Brainy Building. Now we also know L and T, they have to be assigned to the same dormitory. Can they be assigned to Genius Hall? No, because in that case, the number of people in Genius Hall would go up to 5, which would contradict the condition of at least 3 students being in the each dormitory. For the same reason, they cannot be allotted to intellectual center. The only possibility L&T could be assigned to is the brainy building. Now, the only left out person, S, would be allotted to genius hall because each dormitory should have minimum 3 students. That's a case 1. If I make the second case here, that I'm allotting M to intellectual center. So Q also coming with M. And as I said, P and U would alternate between genius hall and brainy building as they cannot come together. L and T could come with any of them if I'm assigning L and T here. Now this assignment is not possible. Why? Because L and T would come together. So we would be getting 2 groups of 4 students each, which would contradict the at least 3 conditions. So this particular arrangement or this particular distribution of students wouldn't work. So this case cannot work, that M and Q would be given to intellectual center. Third case could be OR, MQ goes here and U, and this would just be the replica of the now let's look at the condition. We have to answer which of the following cannot be true. O and U being in the same dorm, that is possible. That is very much possible, as we have seen. O and U can be in the same dorm. So this is possible. This cannot be my answer actually. R and P in the same dorm. Again, that's possible. So this is not my answer. Q and S in the same dorm. This is possible. Cannot be my answer. U and L in the same dorm. Again, this is possible. So cannot be my answer. M and T in the same dorm. No, this can never happen. And that's why this is going to be my answer here. Now let's see what is in this question. Here we have to answer which of the following must be true for the group of 10 students, and with the original condition we know O and R must be in the intellectual center, and we know MPU are in 3 different dormitories. So one of them would go to genius hall, one of them would go to intellectual center, one of them would go to brainy building. Now L and T coming together, if I allocate L and T to genius hall, the balance 2 members would go to brainy building because 4 people are being accommodated to genius hall. And if I reverse this condition, that I am allotting L and T to brainy building would have 4 students, and as we have seen, the distribution of students can be 3, 3, 4. So the other 2 students would go to genius hall. Let's have a look at the options here. Which of the following must be true for the group of 10 students? Exactly 3 students are assigned to genius hall. Now, this is not a must thing to happen. It can happen. Okay, it's not mandatory that it will happen every time. So this cannot be our answer. Exactly 3 students are assigned to intellectual center. Now, this is happening in both the conditions, as I've made 2 cases here. In whichever way we put L&T into genius hall or brainy building, the intellectual center will always have 3 students in it. So our answer should be option number B here. So here, as you can see, we will have to take into consideration every possibility. It's not that I can answer my question only on the basis of one possibility. I will have to take a look at every possibility and then finally go with my correct answer. Now here in this question, again there's a specific condition given to us, which is if U is assigned to same dorm as S, how many distinct group of students could be assigned to genius hall? Okay, so let's start with first possibility, that I'm assigning U and S to genius hall. Now, if U is in genius hall, out of M and P, one would be in intellectual center and the other one would be in brainy building. As far as L and T are concerned, they can only be allotted to brainy building now. Otherwise, we would not meet the condition of 3, 3, 4. And the one who's being left out here is Q would go to genus Hall. Now with this particular arrangement, I am getting two distinct distribution, with M being in intellectual center, P being in brainy building, and vice versa. So we have two distinct distribution here. Let's look at the second case. Now we are saying if U is assigned to the same DOM as S, so let us assign U and S to brainy building. That means M and P would come here, or M or P would go to genus Hall. L and T comes here, and Q comes with USQ. Again, this would give us two distinct possibility. In one case where M is in the genus Hall, P is in the intellectual center, and the other one where P is in the genus Hall and M is in the intellectual center. So two more distinct distribution can happen here. So I think that is the only two ways where we can distribute these peoples like this. We cannot allot U and S in intellectual center, because in that case our rest of the conditions will not be fulfilled. So our answer here should be 4, not 2. Just take care of that, because when I'm writing M/P, that is actually I'm talking about two different possibilities here. Now here we have a question on team formation. In this question we can see there are 10 members in a department. The names are A, B, C, D, E, F, G, H, I, J, and there is a proposal to form a team among these members, but that is subjected to some conditions. Now let's understand the conditions. Condition number 1, the team must include exactly one among E, G and H. So what I have to understand from here, out of E, G and H, I'll be only picking one. I cannot take all three together. A team must include C or F but not both. Again, out of C and F, I can only choose one person. I cannot take both the person at the same time. B and D cannot be a member of the same team. B and I cannot be the members of the same team. If a team includes A, then it also must include B and vice versa. So that means essentially saying that A and B will always come together. If a team includes one among H, I, J, then it also must include the other two. So if I'm taking H, I and J will tag along. Or rather, if I'm taking I, H and J will come along. If I'm taking J, H and I will come along. Okay, so these are the 6 major conditions that are being mentioned here. Now, first question is, what would be the size of the largest possible team? Now, when I want maximum people to be part of my team, I will first try and pick the largest group available, which I can see here, H, I, J. Because the moment I take any one of them, the other two come running with that person. And now we have also ensured this condition that out of E, G, H, I have taken H. So I cannot take E and G. Can I take C and F together? No. I can take one more person, and that person could be either C or F. Because there's been a condition given that B will not come with I cannot take B here. If I cannot take B here, I cannot take A here, because they are appearing everywhere together. So A and B are ruled out. And the only other person I can take is D. So what could be the size of the largest possible team? It could be 5. These 3, one out of these 2, and this one. No way we can exceed the size of 5 here. We cannot put the 6th member here because of the conditions that are being mentioned in the question. And as I've mentioned, that writing conditions like this saves a lot of work, that I don't have to go back to my conditions again and again. What could be the size of a team that includes A? Now, I have to ensure that A is a member of the team. The moment I take A, I'll have to take B because they are appearing together. If I'm taking B, D and I are ruled out. And if I is ruled out of this E, F, H, I cannot take H. You need to understand B cannot go with I cannot go without H. So if I'm taking B, that's ruling out the possibility of H being there. So I can take anyone out of E and F. Sorry, E and G here. It's E and G. So I can take anyone out of E and G. So one person will come from this group. And out of C and F, one person will come from these two. Can I take anyone else? I have already ruled out H, I, J, D has been ruled out. 4 persons have already been ruled out. Out of these two groups, only one can be selected. Both cannot be selected. So what could be the size of a team that includes A? Our answer here should be only 4. A, B, one person out of E and G, and one person out of C and F. I hope it is getting clearer to you how we have to approach these kinds of question. I hope you are paying attention here that we have to solve each question individually here. We cannot solve this like puzzles or arrangement where we can get the entire sorting of data once and then we can move to the question. It's not like that. Every question is a new question here and has to be attempted independently. That's what makes the conditional puzzles actually much lengthier than the conventional classification puzzle or scheduling puzzle, or for that matter sitting arrangements. Now here in this question, in how many ways can the team be constituted so that the team includes D? Now I have to include D. So the moment I take D, I'm ruling out B from becoming a member of the T. And if B is not there, A can also not be there. Out of E, if I'm taking E, out of E, G, H, if I'm taking E, and out of C and F, I can take any one of them. So there would be 2 ways to form team here. If I'm taking D and then I'm taking G, again any one of C and F can be taken up. So 2 ways to form team here. Then I'm taking D and I'm taking H. The moment I take H, I and J will also come along. Again out of C and F, I have to choose one. So there could be 2 teams. Let me just elaborate how am I saying 2 teams. One team would be DEC, other would be DEF. Then we have DGC, DGF. Then DHIJC and DHIJF. So the total number of ways in which the team can be constituted so that the team always has D happens to be here 6. Now this is where most of the students commit mistakes, that you will count this as one case. The moment I'm writing C/F, that means I'm talking about 2 different cases. In one of the case I'm including C, in the other case I'm including F. So this is something you need to pay great attention to. You need to pay a lot of attention that you have to count this kind of situation as 2 cases and not just one. Otherwise you'll get your answer wrong. And what happens is, in most of the cases, even wrong answer has also been mentioned as one of the options. That, as we can see here, 3 is also being given as one of the options. And if somebody is acting in a hurry and they quickly, okay, there are 3 cases, they might end up marking 3, which would have been a wrong answer. So I hope you have a lot of clarity now how to approach conditional selection or conditional grouping questions, and you need to practice a lot for this, for specifically exams like, as I've mentioned earlier, LSAT. The entire analytical reasoning of LSAT is kind of conditional puzzles. And from the past few years, ALET also has a conditional selection question, conditional selection or conditional sequencing question. So I would advise you to practice a lot on these kind of questions. In the next session, we will be doing conditional sequencing and conditional ordering questions. Thank you. Thanks a lot.